So, hi to all. I'm Što? Okay. Is it okay now? Okay, so I'm Goran. I'm part of Radiona, and I will talk about LoRa and smart city. So, nemam. Sad? Jel bolje? Okay. So, I play around with LoRa for some time, and I have decided to install one gateway at my house so I can play more with LoRa and low power devices. So, and today I will present you a bit about LoRa, a bit about LoRaWAN protocol, and what we do at Radiona with it. So what is LoRa? LoRa is modulation, and it's for us it's a black box, so it's a proprietary modulation, and we control it with just input and output. So we have inputs and outputs, and we just tell the chips that has LoRa modulation to send some things or to receive some things. So it is using a chip spread spectrum. So and that is change the frequency over time to get the data in one direction or back, and it is that chip spread spectrum. It helps us to get signal from noise better. So LoRa, it's working great in noisy environment. So we all know that today there are lots of signals around us, and we need to extract our data from those signals, and LoRa is great at that. So that's why it's used for the wide area network, so it can fly away. It can fly a lot in large distances. So main advantages of LoRa is really long range. It is great battery life, low transmit power. At maximum it can use 25 milliwatts, and if you set it up, it can go lower or whatever you set it up, but you need to be a bit closer. So consumption on transmit is 40 milliamps, and on receive it's 10 milliamps. In sleep, LoRa chip can go under 1 microamp. So it's constructed to be low power, so you can use it for a year. So you can use it for maybe have device that will work for 10 years or so on field without changing batteries or charging it. So main disadvantages of LoRa is low data rate and airtime limits. So at frequencies that we are using in Europe, there are time limits. So frequencies 868, we could use 433, but then the protocols define. If we use the LoRaWAN protocol, he defines the rate. So then we cannot use it even on 433 with large in time. We need to be careful not to pass those limits. So LoRa has only one supplier, so only one firm is working LoRa chips, so that is Semtech, and Semtech is making the chips for the nodes and for the gateway. So only one company produces those chips. There are different types of chips that are for the different frequencies. So we have 868 band, 433 band, and 9.915 band that is used in US. So for the nodes, it's used SX1276, and for the gateways, SX1 301 or 8. Gateway scan difference between node and gateway is that gateway chips can receive the data on 8 channels simultaneously. So when you send the node can only send on one frequency at a time, and the gateway can pick all 8 frequencies from other nodes. So the problem with the gateway chip is that when you receive, when you send the message, you cannot, when you send the message on one channel, you cannot receive on all 8 channels. So downlink is a bit tricky to use, so you need to be careful when you want to send the data from the gateway, so you will lose 8 channels on receive side. So because there is only one antenna and you will produce much noise on the antenna when you're transmitting. So there are 2 chips for the gateways. One is for indoor use and one is for outdoor use, but mostly because it's indoor is cheaper, but mostly it's used outdoor chip because of the range. You want to cover more range, and chips are controlled with SPI protocol, so any microcontroller can communicate with it. So then this was about the modulation, and when we want to use the LoRa, we need to use some communication protocol. So there is few protocols. One of them is LoRaWAN, but there is and this protocol is encrypted, so it has the encryption. There is a good project from the UK, HasNet, that uses the open communication it does not need the gateway part. So you use just the nodes for the sending, for the transmitter and receiver, but you then need to be careful because all nodes must do it on same frequency, so you can only hear it on one frequency. LoRaWAN is different, so you can use the gateway chips, and then gateway will listen all channels that node will transmit. So LoRaWAN is a make protocol for wide area networks. It is designed to allow low power devices. So devices can communicate to the long range. Here are the specification of the LoRa Max, so you can check later. And these are the air limits that I talk about. So in Europe, these are the air limits. So one device per band can be in the air only 1% of time on some bands, and 0.1 time and other bands, and there is one band that you can use 10% of time. Usually this is reserved for the downlink from the gateway to nodes, because gateway needs to talk to lots of nodes, not only need to send the data to the gateway. But then you will have the problem with so gateway has the same limits as the node. That is one more problem, and the problem with that you will when you're sending, you will lose all 8 channels on receive, so that is a bit tricky to use. So there is, about this protocol, one guy did the complete, let's say, disassembly the protocol, so you can check the GR LoRa on Git. There is more about the modulation and more about LoRa, making it a bit understandable how it works. So this is the time spent on there, so you can, and the bit rate, so you can check it out that if you want higher bit rate, you need be more time in the air. So if you want lower bit rate, then you will only be a small amount of time in the air, and that is important because you don't want to you want to allow other devices to use the same network, so you want more and more devices, and you want that the device can be as short as possible, send the data to the server, so to the gateway. This is using SF12. The air time is usually, when you send a message, about 40 bytes. Usually take about 2 seconds and each lower spreading factor is half of that time. So 7 is sending about in milliseconds, and SF12 is sending in seconds. So this is because you have a time limit, that's really important. So you want to send, if you want to large for the LoRa, large amount of data, then nodes need to be closer to the gateway, because depending on the SF you will get the lower or higher range. LoRa protocol is supporting 3 classes, so one class is class A. This is a class that is used on the battery-powered nodes. So usually you want to sleep as more as possible, because you don't want to drain the battery. B class is a bit different, so you just tell the node to send and receive data on the exact time, but B class is, you need really good timing, so usually B class needs GPS on the node side, and class C is usually for the devices that are on some power source, so it can receive it at any time. You can send a message from gateway to node at any time. Let's say street light would be a good example of using the class C, and for class E would be some node that is far away on some field and collecting data and sending it to you. When the node is sending the data, he will wait for the gateway to respond. It will open 2 windows, and in that time the gateway needs to send node the data back. It will do that on the same frequency. If a message did not arrive, you can send it on the frequency that is defined by the default. So that is the frequency you can use 10% of your time. There are 2 ways the node can attach to a network. One is OTA, one is ABP. The OTA is using generating keys on the node and the server side. So they are not exchanging the keys. They are just generating it by ID. And ABP join is you have the keys on the node and the server at the time of flashing your device. So ABP join is less secure, because someone can track your messages and maybe extract it extract your keys from the device, and then you cannot change those keys. And the OTA is a bit secured, because it's when you power it up and it will generate it again, and when it passes some counter it will generate the keys again. About the network infrastructure, so we have the nodes that are sending the data to the gateways, and then the gateway sending the data to the packet forwarded to the network infrastructure. So we have the network server that has one key, and the application server that has another key, and each one is decoding the message. So only the applications on application server you can see the real message of what node did transfer. There is a complete open source solution for your server, so you can deploy gateway bridge by broker. You can deploy network server and application server by broker. It is written in Go language, so it is not hard to deploy. There are already made images for the Docker, and there is an application version, so you can check it out. Or you can use already finished solution, that is the Things Network. But this is, if you want it on your server, it is a bit hard to deploy. but yesterday they released the V3 that should be easier to deploy on your server and should be manageable to use in intranet, because they want to expand the use cases for the servers. So one plan is to have it on the large ships, so they deploy complete infrastructure on the ship, and the container will have all nodes and send data from container there. And usually on ship you don't have the network infrastructure that can support complex solution. LoRa is all about a compromise, so it's not for the lot of data and not for time critical data. So you need to think about it in a byte. So when you think about sending data with LoRa, think about small stuff, so like temperature, like bit door are open, door are closed, someone has arrived, it's not, something is present, it's not a present, so not the data from it will be hard to send image or something like that. So you don't send a lot of data, you send just a bit of data that are describing your needs. So from those three things, you need to choose two. And this is what we did as a makerspace. So I was playing around with my nodes and my gateways, and then Radiona decided to deploy a few more gateways in the city so everyone else could use it. So because we all want to experiment and with new technologies, and the price of the gateway is a bit higher, so not everyone can afford it, and I don't like people coming around my house, circling around and testing it. So we try to build it for a wider community. And so we had two workshops. One was with building our own gateways, and one was mapping the city with nodes we created and going around and checking the signal. Our newest gateway is presented outside, so this is the complete open source gateway with the Raspberry Pi Zero and the rack wireless concentrator board. Some around cost of these gateways, so about 200 euros. When you buy the concentrator board is a bit expensive, but Raspberry Pi Zero it's cheap. So, and antenna it's not problem to buy antenna. It is cheap version of antenna, but for antenna you can build it yourself. Boxes from some local shop, and you just need to put it on some higher place and use it on the network. These are the results of our city mapping, and this is the coverage of current coverage of our gateway. So at each point we passed all those places, and the node did send a message with the GPS coordinates to the server and map the place with the signal power. So now we have on those places you can try to put your nodes or something else. So this has the best coverage. You will see that when you need to deploy gateway on the highest place possible, so then you will receive the signal much better. So it can go through the buildings and so, but if you want the range, it's best if you can see the gateway or at least have some visibility to it. So at one point we were hiking on the Sljeme local mountain, Medvednica local mountain on the tower Sljeme, and tried to get the bits of the range to have a feeling how long can LoRa fly, and with SF8, one node managed to get to the Karlovac, the city that is 54 kilometers away from Zagreb, and another gateway with the SF12 managed to get from Zagreb to Maribor, that is 74 kilometers away. So LoRa has the great range possibility if you set it right, if you have the right antennas on both sides, and it can do that with really consuming low power. There are few use cases for the LoRa that I pointed out. So we was at a week ago visiting IRLAS, the institute, and he has the great examples. They have the great examples of how to use LoRa. So they have one counter for penguins on the pole. They just have the Raspberry Pi Zero that is connected to a shield they developed, and shield is using the Zero, so they send the Raspberry Pi to sleep, and it's consuming 100 microamps in sleep. Then the shield is powering up the LoRa, taking the picture, then OpenCV counts the penguins, and then the number of penguins is sent by the LoRa to, because on the pole there is a limitless internet infrastructure, so you need to send it on the large distance to get those data. So you can get complex data on the large distance with those kind of thinking. So they have another one that is speed stop for turtles. So turtles has on its back, it has the LoRa node, and when it's in the sea, you don't have the signal, and you can measure the signal. If it gets out, then you know that the turtle is present there, then you can change the batteries, get the pictures or videos from the Raspberry, and exchange it, because it's consuming power when it's consuming power when it's taking the picture. You can change this backpack of turtle. That's why it's called the pit stop for turtles. Another example was in Africa there are lots of poachers, so they kill animals, and then they made some device with the Raspberry Pi. It's just listening the sound and analyzing the sound of the gun, and when the gun hits, then the LoRa sends the message that poacher is on the field, so you need to go there and catch them or something. So our examples are maybe smart birdhouse. Our examples are a smart birdhouse. So in the birdhouse you can put some measuring device and measure the outside temperature or maybe inside temperature and check if the bird is in house or it's not in house or something like that. Or maybe intruder alarm in some distant house or boat. You never know when someone is around or opening or closing door, so you can use LoRa to send on the large distance that kind of signal if someone is near or opened the door. On our exhibition we made some scale that is public, so you just measure your weight and it sends the data to the network. So you can maybe put something that on public places when people run and want to see its weight or something. One good maybe example is pager, so it's just sitting there until you get some mail or something, so you don't have to walk around with your phone. You can just have LoRa and it will report you when someone is maybe calling you or something. GPS for pets, there is one project for the GPS that is low powered, so it's sending the data each hour and it's sending the location around in 100 meters, and it's consuming some microamps, so it can last for 10 years without charging. Maybe pollution detection or something bad is happening, then it sends the warning, agriculture, plain soil, and there are so many use cases, but you just need to think about it in a way that is that you send as less data as you need. So you just need to think about the low data. And one warning that I did, this is my gateway at my house, and it was white before I mounted it on the near the chimney and heated my house, and after a few days it is looking like this, a bit black. Yeah, so this is it. Thank you. And if you have some questions, yeah.